It is an enforceable violation to install single-pole breakers in a panel board marked for use with two-pole breakers only. The National Electrical Code, specifically the 2020 edition, provides clear guidelines on panel board markings and the types of circuit breakers that can be used. Article 408.3 mandates that panel boards be marked with the number of spaces available for circuit breakers of each size, as required by the article. This ensures that electricians and inspectors can easily determine the intended capacity and configuration of the panel board. Article 408.3 specifically addresses panel boards designed for single-pole circuit breakers, stating that they must be labeled accordingly. This labeling requirement helps to prevent the installation of incompatible breakers, which could compromise the panel board's functionality and safety. Article 408.54b further clarifies the voltage compatibility of panel boards and circuit breakers. It states that panel boards marked for use only with circuit breakers rated 120/240 volts must be used only with such circuit breakers. This provision ensures that the electrical system operates within its designed voltage parameters, preventing potential hazards such as overvoltage or undervoltage conditions. The explanation for this violation lies in the design and intended use of the panel board. In scenarios where a panel board is designed with 12 breaker spaces, which is a multiple of 2, it is typically intended for use with two-pole breakers. If single-pole breakers are installed in such a panel board, it becomes possible to have an odd number of breakers installed. This can lead to a violation of the 6 movement rule, which is a critical safety principle in electrical installations. The 6 movement rule mandates that there must be a minimum of 6 movements of the hand to operate any circuit breaker in a panel board. This rule is designed to prevent the inadvertent operation of adjacent circuit breakers, which could result in unintended power outages or equipment damage. If single-pole breakers are installed in a panel board designed for two-pole breakers, it becomes possible to operate 2 adjacent breakers with a single movement of the hand. This direct violation of the 6 movement rule compromises the safety and reliability of the electrical system. Consider a panel board with 12 spaces, designed for two-pole breakers. If single-pole breakers are installed, it is conceivable to have an arrangement where 2 adjacent single-pole breakers control unrelated circuits. In such a scenario, a single careless movement could trip both breakers simultaneously, disrupting power to both circuits. This is precisely the type of scenario that the 6 movement rule aims to prevent. The enforcement of these code provisions is essential for maintaining electrical safety and preventing potential hazards. Electrical inspectors are responsible for verifying that panel board installations comply with the NEC and other applicable standards. If an inspector observes the installation of single-pole breakers in a panel board marked for use with two-pole breakers only, it is their duty to cite this as a violation. The correction of such a violation typically involves replacing the incorrect breakers with the appropriate two-pole breakers or replacing the panel board with one that is properly listed for single-pole breakers. It is important to note that the specific requirements and interpretations of the NEC may vary depending on the local jurisdiction. Therefore, it is always advisable to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. In summary, the installation of single-pole breakers in a panel board marked for use with two-pole breakers only is a violation of the NEC and can compromise the safety and reliability of the electrical system. The 6 movement rule is a critical safety principle that must be adhered to in all panel board installations. Electrical inspectors are responsible for enforcing these code provisions and ensuring that electrical systems are installed and maintained in a safe and compliant manner. Electrical systems are the backbone of modern society, providing power to homes, businesses, and industries. The safe and reliable operation of these systems is paramount, and adherence to electrical codes and standards is essential for achieving this goal. Panel boards are a critical component of electrical systems, serving as the distribution point for electrical power within a building. The proper installation and maintenance of panel boards are essential for ensuring the safe and efficient distribution of electricity. Circuit breakers are protective devices that are designed to interrupt the flow of electricity in the event of an overload or short circuit. The selection and installation of the correct type of circuit breaker for a given application is crucial for ensuring the safety and reliability of the electrical system. The National Electrical Code (NEC) is a comprehensive set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is updated every 3 years to reflect the latest advances in electrical technology and safety practices. Electrical inspectors are responsible for enforcing the NEC and other applicable electrical codes and standards. Electrical inspectors play a vital role in ensuring the safety and reliability of electrical systems. The 6-movement rule is a fundamental safety principle in electrical panelboard design and installation. The rule dictates that a minimum of 6 distinct movements must be required to actuate any circuit breaker within the panelboard. This seemingly simple requirement has profound implications for electrical safety, preventing accidental or inadvertent breaker operation. Understanding the rationale and application of the 6-movement rule is crucial for electricians, electrical inspectors, and anyone involved in electrical system design or maintenance. The primary purpose of the 6-movement rule is to minimize the risk of unintentional circuit interruption. In a panelboard with closely spaced breakers, a single, careless hand movement could potentially trip multiple breakers simultaneously if not for this rule. Such an event could disrupt power to critical circuits, leading to equipment damage, data loss, or even hazardous situations. By requiring multiple deliberate movements to operate a breaker, the 6-movement rule significantly reduces the likelihood of such accidental tripping. The 6-movement rule also serves to enhance electrical safety by reducing the risk of electrical shock. When working within a panelboard, electricians often need to manipulate breakers in close proximity to lead electrical components. Requiring deliberate, controlled movements minimizes the chance of accidental contact with energized parts, thereby reducing the risk of electric shock. The 6-movement rule is not merely a theoretical concept, it has practical implications for panelboard design and installation. Panelboard manufacturers must consider the 6-movement rule when designing their products, ensuring that breaker spacing and operating mechanisms comply with the requirement. Electricians must also be mindful of the rule when installing breakers and wiring panelboards, ensuring that the arrangement does not compromise the intended safety feature. Violations of the 6-movement rule can occur in various ways. For example, installing oversized breakers in a panelboard can reduce the spacing between breakers, making it easier to trip multiple breakers with a single movement. Similarly, improper wiring or the use of non-standard breaker operating mechanisms can also compromise the 6-movement rule. Electrical inspectors are responsible for verifying compliance with the 6-movement rule during inspections. They examine panelboard installations to ensure that breaker spacing, wiring practices, and breaker operating mechanisms adhere to the requirements of the NEC and other applicable standards. Violations of the 6-movement rule are typically cited as code violations and must be corrected to ensure electrical safety. The 6-movement rule is not a standalone requirement, it is closely related to other NEC provisions regarding panelboard design and installation. For example, the NEC specifies minimum spacing requirements for breakers in panelboards, which are intended to help ensure compliance with the 6-movement rule. The NEC also addresses the use of barrier strips and other protective devices to further reduce the risk of accidental contact with energized parts. The 6-movement rule is a fundamental safety principle that is essential for preventing electrical accidents and ensuring the reliable operation of electrical systems. By understanding the rationale and application of the 6-movement rule, electricians, electrical inspectors, and other professionals can contribute to a safer and more efficient electrical environment. The NEC provides additional guidance on the application of the 6-movement rule in specific situations. For example, the NEC addresses the use of handle ties, which are devices that connect the handles of 2 adjacent breakers, causing them to trip simultaneously. Handle ties are often used for multi-wire branch circuits, where it is important to ensure that all ungrounded conductors are disconnected simultaneously in the event of a fault. The NEC specifies requirements for the use of handle ties, including the need for clear labeling to indicate that the breakers are connected. The NEC also addresses the use of lockout/tagout procedures for electrical equipment. Lockout/tagout procedures are designed to prevent accidental energization of equipment during maintenance or repair. These procedures typically involve disconnecting the equipment from its power source and placing a lock and tag on the disconnecting means to prevent it from being accidentally turned on. The NEC provides guidance on the implementation of lockout/tagout procedures, including the requirements for training and documentation. The NEC is not the only standard that addresses electrical safety. Other organizations, such as the National Fire Protection Association (NFPA) and the Institute of Electrical and Electronics Engineers (IEE), also develop standards related to electrical safety. These standards often complement the NEC and provide additional guidance on specific aspects of electrical system design and installation. Compliance with electrical codes and standards is essential for ensuring the safety and reliability of electrical systems. Failure to comply with these standards can result in electrical accidents, equipment damage, and even legal liability. It is important for electricians, electrical inspectors, and other professionals to stay up to date on the latest electrical codes and standards and to ensure that their work complies with these requirements. The specific requirements of the NEC and other electrical codes and standards can be complex and may vary depending on the local jurisdiction. It is always advisable to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable requirements. Electrical safety is a shared responsibility. Everyone who works with or around electrical equipment has a responsibility to be aware of the potential hazards and to take steps to prevent accidents. By following safe work practices and complying with electrical codes and standards, we can all contribute to a safer and more efficient electrical environment. The ongoing evolution of electrical technology necessitates continuous learning and adaptation among electrical professionals. Staying abreast of the latest advancements in areas such as renewable energy, smart grids, and electric vehicles is crucial for ensuring the safe and effective implementation of these technologies. Furthermore, a deep understanding of the principles of electrical theory and circuit analysis is essential for troubleshooting and maintaining complex electrical systems. Electrical codes and standards are constantly evolving to address emerging safety concerns and technological advancements. Regular review and updates of knowledge regarding these codes are paramount for ensuring compliance and preventing potential hazards. Engaging in continuing education courses, attending industry conferences, and participating in professional organizations are valuable avenues for staying informed about the latest developments in the electrical field. Electrical safety practices extend beyond technical knowledge and encompass a strong commitment to personal safety and risk assessment. Proper use of personal protective equipment (PPE), such as insulated gloves, safety glasses, and arc-rated clothing, is essential when working with energized electrical equipment. Before commencing any electrical work, a thorough risk assessment should be conducted to identify potential hazards and implement appropriate safety measures. Effective communication and teamwork are crucial for maintaining a safe working environment. Clearly communicating procedures, potential hazards, and any changes in the work plan to all team members is essential for preventing misunderstandings and accidents. Encouraging a culture of open communication, where individuals feel comfortable raising safety concerns, is vital for promoting a proactive approach to safety. The integration of technology into electrical safety practices is becoming increasingly prevalent. Devices such as thermal imaging cameras, ground fault circuit interrupters (GFCIs), and arc fault circuit interrupters (FCIs) play a significant role in detecting and preventing electrical hazards. Thermal imaging cameras can identify hotspots in electrical equipment, indicating potential problems such as loose connections or overloaded circuits. GFCIs and FCIs provide protection against ground faults and arc faults, respectively, which are common causes of electrical fires. A comprehensive approach to electrical safety involves not only technical expertise and adherence to codes and standards, but also a strong commitment to personal safety, risk assessment, and the effective use of technology. By embracing these principles, electrical professionals can create a safer and more efficient electrical environment for themselves and others. Remember to always energize circuits before working on them whenever possible, and to use appropriate lookup/tagout procedures to prevent accidental re-energization. If you are not qualified to work on electrical equipment, always hire a licensed electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice.